In this video, we're going to be taking a look at some work and power problems in order to discuss some concepts and different types of calculations relating to work and power. So, work is the amount of energy transferred either in or out of a system. In all of these cases, we have a positive work value because a force is being applied in such a way that it is adding energy into the system or the object. So, our first one is our most simple case. We have a box that's being pulled with 50 newtons of force, and we're going to use the formula work equals force times distance. And with that formula, it also involves the cosine of theta if there's an angle involved. And in this case, there's not. So, if it's being pulled with 50 newtons and it's pulled a distance of 3 meters, you would just simply find the product of those two and take 50 times 3, and you would get 150 joules, which means that whatever thing is pulling the mass right there is basically adding 150 joules of energy to that object by doing work on it. Secondly, if we're taking a look at the power, power is time dependent, which means that we want to take power and set that equal to work over time. So power is the rate that work is done. So we want to know how quickly that energy is being transferred. So say, for example, you want to find the power being exerted in that 2 seconds, and you want to show the power in 3 seconds. You would just simply divide the work divided by the time. 150 divided by 2 is going to give you 75 watts. And then 150 divided by 3 is going to give you 50 watts. And watts is also known as joules per second. So it's how much energy is being added to that system per second. Now, if you do that quickly in 2 seconds, then that power rating is going to be a little bit higher. And then if you take a little bit longer, 3 seconds, then that power value is going to be slightly lower. All right, now taking a look at the next case, this one does have an angle. So we have work equals our force of 50 times that same distance of 3, but now we're going to add the cosine of 60 degrees. And basically what that does is it basically just finds that horizontal component, because that is the main component in adding kinetic energy to the block. The upwards component is kind of tugging it up a little bit, but that's not actually changing the amount of energy that the block has. So we take 50 times 3 times cosine of 60 degrees, and then we end up getting 75 joules of energy being transferred to it. Now, say for example, you want to do a power calculation. This one is slightly different. It's telling you that the power output is 100 watts, and it's asking you to solve for how long that would take. So power equals work over time. And what you could do is you could multiply both sides by T, and then divide both sides by 100. And then you would have your answer, which is 75 divided by 100. So it means time is 0.75 seconds in order to get the power output of 100 watts. So to sum things up, with work, you basically just do force times distance. And if an angle is involved, you want to make sure you include that angle as well. And if you have some kind of power calculation, then you want to consider the time so you can find the rate that the energy is transferred. Now let's take a look at this final case over here. We have a box being lifted up 1.5 meters off the ground. Let's assume that it's pulled up at a constant velocity, so the force being applied to it is constant and not changing. And it is being pulled up in about half a second. So in order to find the value of how much work is being done, we want to find the force, which that's mass times 9.8 mg, the weight of the box. So this is going to account for the F. And then the distance is that 1.5 meters that it's pulled up. If we find the product of these three things, we get 29.4 joules. Secondly, we want to go ahead and find that power output. The power output is, again, taking that work value of 29.4 joules and dividing it by the time value, to find the rate of how many joules were added to that box per second, and then we get a value of 58.8 watts. Okay, and the slight differences, which you can't really tell from my handwriting, is that watts is a capital W and then work is a lowercase w. All right, so there's some basic calculations for work and power, so I hope that was helpful in helping you understand those two different values. Thank you for watching and listening.